Swayam Prabha. Digital India. Educated India.
A very central topic of our presentation is inference, which is a tool for reasoning. So I welcome you all to this new session, for which the central topic is reasoning. But before we go to that, we need to review perception a little bit. It's a very brief review because a few things are to be covered, and then only we can talk about inference. So this is a case of valid cognition or knowledge where an apple is captured as an apple. The point is here, you can either say that the qualificant, of course the qualifier is appleness, the qualificant is an apple, or the qualificant is this. It depends. This italicized this actually is the reference of the word this, as I have said. So the point is, it doesn't matter which way you look at it. If the cognition is like this is an apple, then this would be the qualificant. If it is just apple, then it will be the apple itself. Strangely, even for this case, the qualificant, if the understanding is apple, then the qualificant is, the qualifier remains the same, right? Appleness, even for this case, because something is captured as an apple. But the qualificant changes. It's a pair. So it is a cognition whose qualificant is a pair, but qualifier is appleness. Or alternatively, if you cognize it as this is an apple, then the qualificant is this, and the qualifier appleness. The point I'm trying to make is the following. Here, the qualificant hardly matters. After all, what you capture, the qualifier is the main thing, right? Why is it the main thing? Because something is a mere something. It's capturing means it's capturing as having some property, as something having some property. That something part is kind of neutral, and that is the reason the QR plays a much important role here. There is a principle, general Nyaya principle, which states dharmini sarvam abhrantam prakaretu viparyayaha, which means that the qualificant has nothing to do with invalidity or error. The error affects the qualifier. It does not matter whether the qualificant is this or apple or pear. There is a small difference between this on the one hand and apple or pear on the other hand. When you say that for this cognition the qualificant is a pear, although the qualifier is appleness, you kind of take God's perspective. So to say, you take kind of a omniscient perspective. You know that what is captured is not an apple, but it's a pear. So it is something like, it's kind of an all-knowing thing. But otherwise, you are neutral. So for example, the person who has the illusion would never say that a pear is the qualificant of their cognition apple, right? Because it is, the pear is being cognized as an apple. But the cognizer does not know that. You, as a neutral person, as a third person, you almost as an omniscient person can say that here is an illusion whose qualificant is a pear, not an apple, but the qualifier is appleness. So the point is, what matters is the property that qualifies the qualificant. The qualificant does not play any role as far as the mistake is concerned. With this, it is just to this is what I wanted to say about the qualifier. So that now, for reasoning, for inference, these things will be very important. How to analyze something and then how to talk about those. We start our session on reasoning with formal logic, which is a central tool for cognitive science in Western academia. Formal logic has been used as a tool for understanding reasoning. What is this formal logic? I assume that all of us know a bit of logic, bit of formal logic, but still, for those who do not know, here are a few important rules, and I'm not going to explain all of these, but I'll show a few. I'll demonstrate a few. For example, take rules about and. So the first rule introduces and the second one removes it. So the first one is called conjunction. How is it? It is alpha and beta. Alpha is given. Alpha is asserted, and also beta is asserted. From that, you can conclude that alpha and beta is asserted. This is called conjunction. So an example, Ram is a student, John is a student. From that, you can conclude Ram is a student and John is a student, right? So this and has been introduced now here. And how could you remove it? You could remove it this way. Alpha and beta. From that, either you can conclude alpha or beta. So example, Ram is a student and John is a student. From that, you can either conclude Ram is a student or John is a student. We go to the next rule, which is or. What is or? When you say alpha or beta, you are claiming at least one of them is true. You are not saying that both cannot be true. Even both can be true. But your claim is at least one has to be true. So the first one is once again introduction. So you assert that Ram is a student. You assert means you announce that Ram is a student is a fact, right? Then from that you can conclude anything. Ram is a student or John is a student. Here, the truth or falsity of John is a student, the second thing which is added, does not matter at all. Why doesn't it matter? Simply because the first one is asserted. That means the first one has been established as a true proposition. Then the second one does not matter because your requirement is at least one has to be true. And the first one is already true. So what you add to that does not matter. So that is how or is introduced here. And the second one is typically an elimination rule. So you have this alpha or beta. Now elimination, as far as or is concerned, is difficult because it is not enough to have just one thing. So for example, one thing in the sense, if one disjunct, these both are called disjuncts. So alpha or beta, if I assert alpha, that hardly proves beta because so the point is, how do I know? If you want to remove it, you need to know that one is false. Then the other one must be true. That is how surely you can remove it. An example, Ram is a student or John is a student. You know that one of them must be true. Then somebody says that it is not true that John is a student. Then you are left with no option. You have to accept then that Ram is a student must be true because one of them must be true and the second one is not true. Therefore, the first one must be true. This thing in the Indian framework is called parisheshya nyaya. Parisheshya means the residue, whatever remains. Right here, Ram is a student is kind of a residue because the second part is being denied. So then whatever remains has to be true. Then we go to the if-then rules. The first rule is modus ponens, which is an elimination rule. So the point, this is all the time we use this rule, knowingly or unknowingly. If Ram is a good student, then he is intelligent. Ram is a good student, that is asserted. Therefore you conclude, then he is intelligent. And the second one is, Alpha implies beta, neg beta, therefore neg alpha. This is called modus tollens. So we write it as MT. If Ram is a good student, then he's intelligent. Then you assert that it is not the case that Ram is intelligent. That denies the very first part of it, that is, Ram is a good student. So you conclude that it is not the case that Ram is a good student. It is not possible, right? When you say that, if Ram is a good student, then he has to be intelligent. He's not intelligent, therefore he cannot be a good student. But the opposite is not true. So to say, if Ram is a good student, then he's intelligent, and then you say Ram is not a good student. That doesn't mean that he's not intelligent. Maybe he's a good pianist. Maybe I don't know, he's a good athlete or something. So, and very intelligent one. So being intelligent has nothing to do with being a good student, right? So yes, if somebody is a good student, there is guarantee that that person is intelligent, but not the reverse, right? So we understand these very basic rules, and then we can do a few problems now. For example, consider this argument: Ram is intelligent. Let that be abbreviated as R. And it is not true that John is intelligent, which is J. If John is a good student, that is G, then John is intelligent. If John is not a good student, then he is not employable. Therefore, John is not employable. Now, if you look at this argument, it may not be very easy for you to say whether this argument is correct or not. Whether John is not employable can actually be concluded from the premises, from the given ones. But this tool, that is inference, that is formal logic, makes this conclusion much easier. How? You symbolize it. Ram is intelligent, and so this is the and. Remember, and it is not true, that is this neg. It is not true that John is intelligent. And then you say if John is a good student, then John is intelligent, which this is if then. So basically you are saying if G, then J. And then you are saying that if John is not a good student, so neg G, then he is not employable, that is neg E. You have to show, that is this, just write show John is not employable, neg E. How do I show it? First, I take this out, simplification. We must remember this, that this is the elimination rule for and. We just eliminate this one, because when this is given, any one can come out, if you remember. So neg J comes out, we call it one simplification. It is a case of simplification, and it is applied to the first premise. And then we do, by using 5 and 1, we do modus ponens. We do modus tollens, because it applies here. You have got this, a negated thing, a denial, and denial of the second element. So by denying the second element, you deny the first element of this if-then sentence, that is 2. And then 2, 5 modus tollens. And then 7 is once again a modus ponens. You get neg G, you get neg G implies neg E. Therefore, you get neg E. That is 3 and 6. 3 and 6 modus ponens. So you can sort of guarantee that yes, this argument is valid, because I can formally conclude its conclusion. Now, this is a very easy argument, I must say, if you just read it a couple of times, if you are not very familiar with logical things, even then you can figure out that this argument is fine. But not that all arguments appeal intuitively. There are some very complex arguments for which we need some kind of computation. So here is our computation, and this is a process. We have been talking about process and computational procedure and all that stuff. Here is one. And now predicate calculus, which is complicated in itself. A little bit we can talk about. So there are basically quantifiers. We understand this when we deal with translations. We need to translate every good student is intelligent. How do we translate? You just write for every x, which is this, for every x. If x is a good student, then x is intelligent. Then you are saying that you choose anything. If it is a good student, that thing, then it is intelligent. That means you do not find a single unintelligent good student. This is basically is said here, that is for all x. If x is G, then x is I. Some good student is intelligent. You are not claiming that everybody is such that if he or she is a good student, then he's intelligent. You are saying that some good students are intelligent. So you are saying that there exists some x such that at least one x, some means at least one, such that it is a good student and it is intelligent. Then you are saying no good student is intelligent. Basically, you are saying for every x, you choose anything. If it is a good student, then it is not intelligent, which is precisely this. And finally, some good student is not intelligent, which is for some x, x is a good student and x is not intelligent. So this is your translation. I think now we understand these are the quantifiers. This is all and this is some. I think we understand a bit about quantifiers. Now we go to an argument. All good students are intelligent, which is for all x, if gx, then ix. Ram is a good student, that is gr. Show ir, that is Ram is intelligent. How do we show that? We first do an ui. We instantiate over this thing. That is, instantiation means getting rid of this quantifier. We just write gr implies ir. We can use any because this is saying for everything this must be the case. So for r also this must be the case, right? Theoretically we understand. So therefore this stands completely correct. Gr implies ir. And then gr is given. So you do modus ponens, right? That is 2 for modus ponens. And you get ir. That is the conclusion. Therefore Ram is intelligent. This is a very simple problem. There are complex ones and we are not getting into that. But now there are a few issues, not with formal logic, but using formal logic as a tool for understanding human reasoning. The question is, do human beings actually reason in this way? Does it happen this way or not? So do we just think in terms of premises and symbols and in terms of formal things and all that stuff? So there was some experiments as far as that is concerned. This is a very famous one. This is Wason's selection task that was conducted in 1966. I take it from Taggart's textbook, and I'll give you the reference. So the point is, what was the experiment? So you tell people that you guys need to test a hypothesis. What is the hypothesis? If a card has A on one side, then it has 4 on the other side. So this combination was given. So this is from page 36 of Taggart. So this combination was given to a group. Now you see you have A, B, 4 and 7. You need to turn over the cards and then you need to check the relevance of you need to understand the relevance of each and every card here, and then you need to check what happens. Now as far as, so which cards are irrelevant for this and which are relevant? That is the question, right? People often forget to turn over this one, this card with 7. That's a problem. Why is it a problem? You understand that B is irrelevant. It doesn't matter whether B has 4 or 5 on the other side, but A is definitely relevant. If you turn it over and if you find 5 or 6, that is not 4, then definitely your hypothesis is not correct. And you take also 4, you turn it over, if you find B or C, then definitely this is not correct. But many people do not turn over this one with 7. Why so? But it is very relevant. Why so? Because if you turn it over and find A, then once again your hypothesis is falsified. People often fail to understand the relevance of this card. So then many conclusions were drawn on the basis of this experiment. One is this famous Johnson, Laird and Byrne result, or whatever you call study, that claims that when people interpret a conditional such as if a card has an A on one side, then it has a 4 on the other, they construct a mental representation, something like this, that is this A along with 4. Here this A, this thing indicates a model in which a card has an A on it, and for adds that in this model, it also has a 4, and then you construct a complex like this. So these are two sides. Then Johnson, Laird, and Byrne explain many people's performance in the selection task by supposing that they consider only those cards that are explicitly represented in the models of the rule. For example, so if that is the figure A4, then this is physically relevant. This is physically relevant. This is not, and this is not. But this is actually relevant. So had formal logic been one way of human reasoning, this also should be, because according to formal logic, this also is relevant. But then people do not go the formal logic way, right? What does it mean? It means that people believe people. So when people actually reason, they have model-based understanding of things, not really axiom-based understanding, symbol-based understanding. The same applies to predicate calculus also. Look at this experiments with predicate calculus. The same Johnson-Laird and Byrne study with this. For example, when you conclude that all football players can lift heavy objects, according to formal logic, the premises could be like this. Anyone strong can lift heavy objects. All football players are strong. Therefore, all football players can lift heavy objects. So it is kind of a deduction, and the formal representation would be like this. For all x, Sx implies Hx, and for all x, Fx implies Sx. And then you do kind of hypothetical syllogism, and as a result of that, because this Sx and Sx are common, it's like a cross. So you can then easily show that all football players can lift heavy weights. So I actually have made a mistake here. It should be slightly different. So the conclusion should be Fx implies Sx. But yeah, you can correct this one. So here it should be actually anyone strong can lift heavy weight. So Sx implies Hx, which is correct. Then the next sentence, all football players are strong. All football players are strong, which is correct. So then it should be all football players can lift heavy weight. So this should be actually Fx, which I didn't do. So I correct this one. It should be Fx. This should be Fx, and as a result, you should have Fx here also. Do the correction, please. Okay, so but the experiments show that people do not reason this way to conclude this. Rather, people make a model where all football players are strong and all of them can lift heavy objects. So there is not a single football player in the model that is not strong and that cannot lift heavy objects. So people perhaps do not think this way. Most studies on Wason selection test suggest that human beings perhaps do not think, I already mentioned that they do not think formally, they do not think axiomatically, that is, having some symbolic forms in their minds, and then they fill up those things and they sort of they prove theorems. Nobody proves theorems when they think or they argue. Rather, people tend to think in terms of models. Models means in terms of real things, combinations of things that can be very complex, but then still these are combinations of things. I think the Indian theory of inference is one kind of reasoning which we call anumana. So the Indian theory of inference is actually based on model. So it is perhaps closer to the real human thinking than the Western formal logics are. Formal logics are great in their own way. They can do other things. But when it comes to simulating the human reasoning, perhaps the Indian logic or the Indian theory of inference is slightly more, slightly stronger, I would say. Okay, so now what it is. So it is something like this. Here is a hell. It has at the same time smoke and fire. And here is a blacksmith shop, which I will call blacksmith for the sake of convenience, that has just fire because it has got a red hot iron ball which has fire without having smoke. And our picture has a sacrificial place, Yajna which has both, once again, smoke and fire, and it has a kitchen that once again has both smoke and fire. Now somebody comes to see that and sees that what is the observation of the subject. The observation is everything having smoke has fire, having smoke has fire. Not the reverse, not that everything having fire has smoke, because the red hot iron ball has fire without having smoke. After having observed this, what happens is, this is once again the perception part. Now, after having observed this, this is the mere observation, this is not theory laden, and how the theory is born this way. So consider this just, sorry, I just take some time for this laser pointer. So assume that this is not a case of fire. This is rather fireness itself, the property of being fire. And this is not just one individual case of smoke, but this is smokeness itself. In that case, when somebody observes that, like the basic observation is this, when now this gets converted into a piece of data, what actually happens, these two universals, that is smokeness and fireness, the universals themselves become sense-object connections. They establish themselves as connection, and the cognitive system of the subject sees that, well, every case of something having smokeness is a case of fireness. Now, this kind of generality, this kind of every case, this kind of all cases having smokeness has fireness, this kind of generality could not be generated had it not been a case of some kind of universal perception or the perception of universals. That is why. So they believe in this very strange, extraordinary perception called Samanya Lakshana Pratyasati, or Pratyasati is the connection, and the perception based on that is also extraordinary. So I translate it as universal only connection. So this is nothing but the universal. The universal itself becomes a connection. So this is how it gains universality. And after having made that hypothesis, that is this anything having smoke has fire, when one goes somewhere and sees smoke, one infers fire. We'll see that. Before that, a bit of technical words and stuff. So what is it? One concludes here. Anything having an entity, this is our term, our representation, anything having an entity limited by smokeness, that is smokeness limited entity, must have fireness limited entity. It is not about one specific entity or two specific entities. It is rather about smokeness and fireness. Here, the thing that is being inferred is the target or sadhya. The thing from which something is inferred is the hetu or the reason, and where the entire inference takes place is the site or paksha, is the locus. So in our case, the target is fire, the reason is smoke, and the hill where the fire is inferred is the site. Now we go to the old picture, the picture of inference. One goes somewhere, finds a hill there, and one doesn't see any fire, but one sees smoke there. After seeing that, here is the chronology of it. After seeing that, one remembers that anything having smoke has fire. Now, this is the Indian rule Indian psychological rule of association, eka padarthaha, eka sambandhi, apara sambandhinah smarakaha. So when two things are associated, A and B, if you see A, you remember B. So then because you see smoke, and because smoke and fire are related, and you know of the relation, when you see smoke, you are reminded of this principle, which is anything having smoke has fire. This is in general terms. This is in naive language. We will talk about the technical language after this. And then one considers this, that this hill has smoke that indicates fire, because one does not see fire there. Then one infers fire there. So this is the picture they have in their mind when, so the fire now figures in one's knowledge. This hill has fire that is indicated by smoke. So another set of central ideas of Indian inference: pervasion, which is the most central. Vyapti is the Sanskrit word for that. What is it? It's a very fact that any case of X is a case of Y. Or, in other words, Y pervades X, or X is pervaded by Y. So, example, any case of smoke is a case of fire, which means fire pervades smoke, which means smoke is pervaded by fire. The second idea, or the second concept, is the site locatedness, or paksha dharmata. What is it? It is the very idea that the site has the reason, right? Without which you couldn't have inferred anything. In this case, it is this hill has smoke. And the third one is consideration, or paramarsha, which is the site has the reason that is pervaded by the target. So this we said that the hill has smoke, which indicates fire. So in philosophical terms, this hill has smoke that is pervaded by fire. And in other words, this hill has smoke, which is such that any case of it is a case of fire. So I just wanted to elaborate on this word, pervaded. So we need to remember these few words: pervasion, site locatedness, and consideration. After that, the steps, the chronology of it. First, one perceives X, and then one knows the site locatedness. That is, this site, whatever it is, has X. This is like seeing X as a reason, not just an ordinary experience of X. It is the experience of X as the reason of this inference. Then the recollection of pervasion, any case of X is a case of Y. Then the consideration. This site has X that is pervaded by Y. Therefore, the last one, the conclusion, therefore, this site has Y. Now, examples of that. So first the subject sees smoke, and then they, in a sense, revisit smoke as the reason, right? So they put it this way: this hill has smoke. So this is kind of tagging. You add a tag to the thing you have just seen. Now it is not just seen, it is seen as a reason, right? A reason from which one can infer something else. Then one remembers any case of smoke is a case of fire. This is our causal instrument, the karana. And then immediately after that, so this triggers the entire process of inference. Then one has this knowledge, that is, this hill has smoke that is pervaded by fire. This is the causal operation. Remember that between the causal instrument and the resultant thing, the result, there is this operation, like it was the contact between the axe and the tree. Therefore, the conclusion: this hill has fire, which is the last of it, which is the result of it, right? Here, one very important thing: what are the claims associated with an inference? So the inference is presented schematically. S has T since S has R. The claims are, first of all, the main claim, that is S has T, which is the inference itself. Second one is S has R. Otherwise, how could I infer T on the basis of R, right? R must be there. And the third one is the pervasion claim. That is, any case of R is a case of T. Now notice here one very important thing. At a philosophical level, when you analyze this is the schema, right? And this schema is presented formally. So actually they would say pakshaha sadhyavan hetoho. So this is a schematic thing. Almost it's a formal symbolic thing in a sense, where paksha, where S stands for paksha. So yeah, the Sanskrit philosopher uses words like paksha, sadhya, and hetu, but actually what they mean by those are variables, right? They're like S, T, and R, whatever stands, whatever can kind of replace those things. And the replacement, that is the instantiation of this, the entire schema would be this. Here is this hill has fire, since it has smoke. Then this hill has fire. And so that is one of the claims, which is the main inferential claim. And this hill has smoke. This is a site locatedness. Without having established the reason in the site, you cannot inferentially claim anything. And then finally, any case of smoke is a case of fire. This is the very basis on which you are claiming this hill has fire, right? So these three claims. Now see, we are claiming that the human mind actually replaces all these things. So these schemata are there in the mind, but the human mind is not aware of that. More than mind, it's the cognitive the cognitive system that is not pretty much aware of these schemata. They see this, and this looks like a model. A model, all those studies suggest, for example, as we said, this Johnson layers and others. All of those studies perhaps indicate that people think in terms of models, right? These are models. Now, this hell. So the first thing is in terms of this hill and fire. The second one, this hill and smoke. Third one is kind of all cases of smoke are cases of fire. So case of smoke, case of fire together. So they form pictures. The pictures are derived from some other symbolic things, which the system, the cognitive system or the subject may not be aware of. But still, what they are aware of is something like this, right? Which are model-like. So the principle is, if any claim is contradicted, then the whole inference is contradicted. So you can contradict the entire inference, that is, this hill has fire since it has smoke, by contradicting any claim. Why is contradiction important? Because now we need to talk about the validity of an inference, both the validity and invalidity of an inference. And what is valid here, very strange. We are not defining validity. Rather, for us, more foundational is invalidity. We are basically defining inferential defects. So, and then the second definition would be the definition of valid inferences. What is it? If an inference is not invalid, if an inference does not have any defect, then it is valid, right? So then what is an inferential defect? An inferential defect, or hetwa bhasa, is actually the content of the valid cognition C. And it is something like this. I read the formal definition. The content of the valid cognition C is the inferential defect of the inference F, if and only if C contradicts any assertion made by F. Basically, such a content is a fact. Look, Indian thinkers, classical Indian thinkers, did not have the word fact, but for them, because for them everything is cognition-centric. So they take a valid cognition, and what is the content of that? Definitely a fact, right? Because what is a valid cognition? When you capture an apple as an apple, your cognition is valid. That means this is an apple, in this case, would be a fact. But when you capture it as something else, as a pear or something else, then what you captured is not a fact, right? That's the wrong thing. So actually here you can replace this by the word fact. The content of a valid cognition C is basically a fact. Now, one example, the valid cognition, there is no smoke on this hill, contradicts the site location or the site locatedness of the inference. This hill has fire since it has smoke. Therefore, the content of the valid cognition, that is, the absence of smoke from that very hill, is the inferential defect in this case. Facts are enlisted on the database. We'll talk about the database later after a few seconds. Now, one very important thing. In our model, what is a defect? What is an inferential defect? It's a fact, at least as of now. We are going to modify this definition. This is a working definition, but it works for most cases. The point is, always, as of now, I just qualify, our defect is a fact. So when a fact contradicts any part of your inference, or rather any claim associated with your inference, then that fact becomes the defect of your inference. So it is invalid if it is confronted, challenged, targeted by a fact. Otherwise, it is valid. We will talk about this idea, the idea of the database. Nayayika, or the logician, does not explicitly talk about the database. They would never say that we do have a database, but this is what we conclude after when we study the Nyaya system, the model. We conclude that there is something on the basis of which they're testing their cases, right? For example, most of it is a few assumptions are there. For example, every case of smoke is a case of fire. But it is not the case that every case of fire is a case of smoke and stuff like that. The water lake does not have fire and all that stuff. So I assume that all these assumptions try to describe some kind of a world. Let it be the real world, but it need not be the case all the time, right? So what I call the database is a list consisting of those assumptions, which are kind of factual. As of now, they're factual. So we may consider one database which looks like this. It has got all these description-like sentences. And hill 1 does not have smoke. Hill 2 does not have fire. Hill 3, hill 4, kitchen 1, and kitchen 2 have smoke. Every case of smoke is a case of fire, and a few others. And so the Nyaya system, the Nyaya logic, or for that case, most Indian logics, are more like semantic systems that have models. This is very important, that they're not just formal logics. They have kind of a semantic structure, and we can now see one hitva bhasa, one inferential defect called deviation, in Sanskrit vyabhichara. Deviation is a defect that challenges the provision of an inference. What is the provision of it? Schematically speaking, any case of R is a case of T. Suppose one infers that hill is smoky since that is fiery, or that hill has smoke because it has fire. What is the provisions claim of it? It's very easy to extract the provision claim. There are three claims, right? One is S has R, S has T, and any case of R is a case of T. So following that schema, we get the provision, which is anything that has fire has smoke. So the last thing, since whatever follows since, comes first, and then this thing goes after that, and you get this format. Any case of R is a case of T. Anything that has fire has smoke, or in any case of fire is a case of smoke. Now this is wrong, since a red hot iron ball, taptayo golaka in Sanskrit, is evidence against that. It has fire without having smoke. So not that every case of fire is a case of smoke. We can see this S4, which is part of our database, and it contradicts the provision claim of this inference that hill has smoke since it has fire. We can see that all the defects are marked in red. Now, this is what I meant by saying that in our case, a defect is a fact. a defect must figure on the list of our assumptions, or it must figure on the database. The second defect we talk about is the unestablished reason, that is svarupasiddhi, which is a defect that targets the site location or the site locatedness. Schematically speaking, it is S has R, right? That is, the site has the reason. So here is one inference. Hill 1 has fire since it has smoke. What is the defect? Hill 1 does not have smoke. The real absence of smoke from Hill 1 is the unestablished reason for the inference Hill 1 has fire since it has smoke. So schematically, you just take the reason, which is this smoke here, and you try to keep that in the site, which is Hill 1, and you see that there is a failure, but that is some part of the database would contradict that. And the sentences of your database describe your world, describe your model. So that is how they are sort of factual. So if something factual goes against your inference, that is any claim raised by inference, then it is invalid or invalidated. The third one we consider is opposition or badha. It's a defect that targets the main assertion of the inference, that is S has T, schematically speaking. Hill 2 has fire since it has smoke. Now S2 goes completely against it. S2 is once again a sentence from the database. Hill 2 does not have fire. Here, the hill without fire is the opposition or badha. So here it is marked red as I have shown. And then you have the unestablished site, ashraya siddhi. Here, ashraya means the very locus of the whole inference, ashraya. That itself is unestablished. It's a defect that partially targets the principal inferential assertion by targeting a property of the site. What is it? Consider this one. The golden hill has fire. Now this one also assumes that a golden hill exists, and that assumption. So it's a part of it. It is none of the claims directly speaking, but it is part of one claim. Which claim? Any claim that involves the site. Basically, the first two claims, that is the site locatedness is basically S has R, or the main assertion, which is S has T. So they both are affected by this. So the golden hill has fire assumes that there is a golden hill, and then S6 directly goes against it. S6 from the database, which says that there is no golden hill. Similarly, the hill has golden fire has the unestablished target, that is sadhya siddhi, because goldenness is always absent from fire. So there is a list of asiddhis. We are not considering all hitvabhasas. It is not possible. It's very complex. But we do a few. We can do more when we get a chance. So here it is S6. There is no golden hill. So we could add there is no golden fire. We could add there is no golden smoke. Each would actually go against some kind of asiddhi. Each would rather be an asiddhi of some kind. And then this is the final hitvabhasa on our list. This is very, very important for all of us. Counterbalancing. This one operates in the following way. Now, the Sanskrit name for it is sat-pratipaksa, which means the pratipaksha, the rival, is sat. It means that this is a case of getting locked in tie. So there is a fight, and two fighters are equally strong. Nobody can defeat the other, and they have got locked. So they have got locked in tie. So this is the idea of sat-pratipaksa. Let us see how it works. Now, this is going to be a very important hitvabhasa defect for us because it's a very unique case. Nowhere else, perhaps in no other logical system, we may find a case like this. I describe it. Here is a paper by Guha and a monstrous inference called Mahavidyanumana and Cantor's diagonal argument, and it talks about the following imaginary case. The traditional examples, conventional examples from Nyaya are very out of context in a sense. They're mostly about sound and eternity and non-eternity. They don't make much sense to the modern person, to the modern academic. So we come up with a new situation where it makes a little more sense, which is a little more contemporary. And as I said, it's an imaginary situation, but it's a near real situation. It could be true. What is it? Some physicians have observed that somebody who eats strawberries every day suffers from a disease called coccinus, and somebody who eats blackberries every day never suffers from this disease. We are not talking about the symptoms of this disease, but it is something, whatever, which has something to do with red. Coccini in Latin means red. Okay. Both these observations are uncountered, which means that they seem to be fine, they seem to be innocent, they seem to have worked in every case, in isolation. So they have found people who consume strawberries every day, and they have seen that none of them, all of them rather, have coccinus. And they also have tested people who eat blackberries every day, and they have seen, the doctors, they have seen that none of them has coccinus. But the problem begins when they find one little boy who eats both strawberries and blackberries every day. The question is, does he have coccinus? How to answer this question? What would be the verdict of the physician? Why is it? Now, here is a problem. The physicians now face a dilemma, since the following inferences counterbalance each other. They're equally strong. The boy has coccinus since he eats strawberries every day, and the boy does not have coccinus since he eats blackberries every day. Both the inferences cannot have factual support. One of them can be true, the other one may not be true. We don't know. Both of them can be false. But there is no doubt that both cannot be true at the same time. But we don't know which one is true and which one is not. So what are the sat-pratipakshas? What are the equally strong rivals here? These two provisions. One is any case of daily consumption of strawberries is a case of coccinus, and any case of daily consumption of blackberries is a case of the absence of coccinus. So one, schematically speaking, so there is one reason, that is daily consumption of strawberries, which establishes X. And then there is an equally strong reason, that is daily consumption of blackberries, which establishes the absence of X or the absence of T. This becomes, these two provisions are, because of their opposition, neither of the inferences here, the inferences are the boy has coccinus since he eats strawberries every day, and the other, neither of them gets established. We have issues with this inferential defect, and that is the reason we may have to redefine the very idea of inferential defect. Why so? Simply because our database cannot anymore consist of facts. We thought that each element of our database was a fact, but that's not true anymore. Why not? Because both any case of daily consumption of strawberries is a case of coccinus, and any case of daily consumption of blackberries is a case of the absence of coccinus cannot be facts, since they contradict each other. Where do they contradict? They don't contradict each other all the time. Look at the beauty of it, beauty of the case. Not that they do contradict each other all the time. There are separate cases where they work fine. They contradict each other when both are found in one person, in one locus. Then they contradict. But they cannot be banished from our database, since each works fine in isolation. So if this little boy did not consume blackberries, then it would be easy for the doctors to say that he has coccinus. If he did not consume strawberries every day, or did I say the other thing? Perhaps. Well, so if the boy consumes strawberries every day, then the doctors could have said, well, our verdict is he has cognistics, because we have seen that. If he consumed only blackberries every day, then the doctors could have said this boy does not have cognistics, because he consumes blackberries every day. But the problem is he consumes both. What was our old definition, first definition of Hitvabhasa, or the inferential defect? The content of the valid cognition C is the inferential defect of the inference F, if and only if C contradicts any assertion made by F. The problem is, this cannot define an inferential defect, since this excludes counterbalance that cannot be understood in terms of facts. As I said, that both the opposing provisions cannot be factual, because they contradict. Two contradictory things means, if two things are contradictory, they cannot both be true at the same time. Also, they cannot both be false at the same time. Whatever. In this case, they cannot both be true at the same time. We need to sort of redefine Hitvabhasa, and that now is our task. How do we redefine? We propose a new definition. That is our def 2. The content of the uninvalidated cognition C is the inferential defect of the inference F, if and only if C contradicts any assertion made by F. So this is the change part. The content of the uninvalidated cognition. What is an uninvalidated cognition? That is defined here. The cognition C is uninvalidated if and only if the invalidity of C has not been confirmed. So it seems to be fine. It seems to be valid, but we don't know whether it is actually valid. In such a case, we call it uninvalidated. So agrihita apramanyaka. This phrase is used by many philosophers, including the author of Siddhanta Muktavali, Vishwanatha, and we have borrowed it from them. Here is an example. In the case of cognistics, both the conditions of perversion, that is like one about the blackberry, the other one about the strawberry, are uninvalidated, since nobody could confirm that they were invalid. Neither of those was confirmed to be invalid. So they're uninvalidated because they work fine. Although you have a doubt whether they're valid, they work fine, right? At least you do not specifically say that this one is invalid. We must note that every valid cognition is also uninvalidated. Although every uninvalidated cognition is not fine, it's not valid. That means now our database can consist only of uninvalidated statements, having both facts and those whose invalidity has not been confirmed. That means facts which are established to be valid and those which seem to be fine, both, even doubtful cases, but cases that work fine. Now can be included if we change our data, the definition of our database. If we say it doesn't anymore consist of facts only, it consists rather of uninvalidated statements that include facts. Now, we can see that even this modified definition is not fine. Why not? Because it will lead you to other problems. We shall perform a thought experiment with the definition of inferential defect. That thought experiment will add a lot of things to our existing knowledge of Hitvabhasas and how it works. So we'll do that in the next session. That is the fourth session. Just before I finish this session, I want to tell you one thing. Look how everything here, every definition, everything can be schematically presented, right? For example, the definition of deviation has got this: any case of R is a case of T. Basically, this is schematic. And the next one, so something which attacks that. So you instantiate it through through a real inference, and you see whether something attacks it, something real. Once again, real means something that exists on the database. And now this one is the schematic presentation of the site locatedness, and then something, so the names, the definitions about of positions, right? So each case can be, or rather is defined schematically. We use ST and stuff like that. They use terms like sadhya, hetu, paksha. But the point is, they are formally presented. But the real inference is never formal. The real inference does not have any symbol. So on the basis of that, somebody, not that somebody derives their inference, somebody really infers something like this hill has fire since blah blah blah. This is a real inference which doesn't have any symbol, any gap, any placeholder, or any variable. This is the beauty, I think, of the Indian system. On the one hand, it can be formalized, its meta definitions, its meta descriptions are all formal, but the outcome, but the naive person who uses it, the naive person who seems to be using this system would never have any variable or any technical thing, any formal thing in their inference. They have real inferences, right? So, and if all definitions are schematically presented, at the same time, their examples are something which go to the naive understanding of things. So that is how it is not formal thinking. It is like the model we talked about in the beginning of our talk, in the beginning of the talk about inferential defects and all that, about inferences. And this, I think, is supported by the studies by Johnson Laird and so many others, that human beings reason in terms of models. I think we have kind of we do have a model. Thank you. We will talk about this we'll continue talking about this in the next session. Thank you very much once again.